We can combine these two laws into one law, and it's got this really original creative name called the combined gas law. It's two gas laws combined together. So we can take Boyle's law and Charles' law and combine them, because sometimes you have two things. Well, actually, that's not two variables. It should be three. I didn't notice that the first time. Because sometimes you have three variables changing. Because the other gas laws were two. You change one and that causes the other to change. But here we've actually got three changing. P, V, and T. So they're all allowed to change. So if we look at this, what's up here? That was Boyle's law, right? P1, V1 equals P2, V2. Because if T1 and T2 are the same, then those would cancel out and they don't matter, and we've got Boyle's law. If we keep the pressure the same, there we've got V1 over V2 and V1 over T1 and V2 over T2. If the pressures are the same, then we've got Charles' law. So this collapses into either of those laws if you need it to. So we're going to follow the same process with this sort of a problem. A sample of a gas has an initial volume of 158 milliliters at a pressure of 735 millimeters of mercury and a temperature of 34 degrees Celsius. If the gas is compressed to a volume of 108 milliliters and heated to a temperature of 85 degrees Celsius, what is its final pressure in millimeters of mercury? Doesn't that sound fun? A lot of numbers in there. That's where a table comes in really handy, because we can pull all the numbers out and organize them so that we can see what we have. So we'll make our table. We're going to have two sets of conditions, 1 and 2. So the first thing we come across is an initial volume of 158 milliliters. So 158 milliliters, and that's a volume. At a pressure of 735 millimeters of mercury. Those two go together. Do you see that? They're given to us in the same sentence, so they go on the same line. 735 millimeters of mercury. That's the pressure. Millimeters of mercury is a unit of pressure, but it also says a pressure of. And a temperature of 34 degrees Celsius. 34 degrees Celsius, that's the temperature. What should we do to that? We need to convert that to Kelvin. So you don't need to show this on your table, although it doesn't hurt. I'm just kind of limited on space here. So 273 plus 34 ends up to be 307. So 34 degrees Celsius is the same as 307 Kelvin. So all those guys went together. The gas is compressed to a volume of 108. So that's our new volume, 108 milliliters. And heated to a temperature of 85. So skip the pressure and go over here and put the temperature in the temperature column. 85, and we need to convert that to 85 plus 273. $358 Kelvin. So we'll write that in here, 358 Kelvin. What is the final pressure? That's the question. Look, in our table we have one empty square. It's the P column, so that variable's P, and it's the second row, so that's P2. That's what we're solving for. Now we've looked at 3 different equations. And so, when you're doing your homework, you've got all these equations available to you just sitting there. You have to choose the right one. Well, look at your table. You've got pressure, volume, and temperature changing. Charles' law and Boyle's law by themselves are not going to work because there's too many variables. So we need the combined gas law because it has all 3 of those variables in it. So the combined gas law is P1V1 over T1 equals P2V2 over T2. Always reminds me of R2D2. Again, we have a fraction. So good idea to just get rid of the fraction, and that'll make things maybe a little more straightforward. This time it's not as critical to clear out the fraction because what we're looking for is P2, and that's in the numerator. So you're more likely to be successful even if you don't cross multiply. But when you're kind of iffy on this, it's best to just do the same thing every time. So P1 V1 T2 equals P2 V2 T1. I took the top times the bottom. Actually, I'll mark it up since we can. So these guys together and these guys together. That's what cross multiplying is. So we got rid of the fraction. Here we have what we're looking for, P2. So we're going to divide by the things that are with it on that side. We want to get rid of V2, so we'll divide by V2. We want to get rid of T1, so we divide by T1. If we do it to that side, we have to do it to the other side. V2 and T1. So let's see if we have enough room to do this. So over here, P2 equals P1 V1 T2 over V2 T1. We have our table. Now we take these numbers and we put them into the equation. Rearrange the equation first. Do not put the numbers in and then rearrange. Okay, one semester I tried doing that because a lot of students like to do that. It was a disaster. Don't do it. Rearrange. The letters are much easier to keep track of than all those numbers and their units. Okay, so pressure 1, we find it in the table, 735. I know it's a pain, but write the unit. Volume 1, 158 milliliters. And temperature 2, 358 Kelvin. Just barely fits in there. Volume 2 is 108 milliliters. And temperature 1 is 307 Kelvin. Look at your units. The kelvins cancel out, the milliliters cancel out, and you're left with millimeters of mercury. If your units don't work out, you either forgot to convert some units to the correct ones, or you rearranged your equation wrong. If you end up with V1 times V2, then your units aren't going to work out because you messed up the equation. This equation now has 2 numbers in the denominator, and so you need to be careful when you do this on your calculator. So I'll show you the way that I do it. So when I punch this through on my calculator, I take 735, and get your calculator out and do this if you haven't been doing that yet, times 158 times 358 divided by 108. And people are generally with me up to that point. Then they want to multiply. You need to divide by 307. Because when you press that divide or times button, what your calculator does is it does all of this math that you had already entered. And so if you press times here, you're going to take that whole thing and multiply. And you're going to end up with a number that is way too big. And so you don't do that, you divide. So you divide by 307, and you come up with, it still seems like a really large number. We come up with an answer. Where can I put it? Should have two sig figs, so 3. 1.25 times 10 to the third. And the unit is millimeters of mercury. Is everybody able to get that on your calculator? Now, if that really, really bothers you to divide by that number when it looks like it should be multiplied, then what you need to do is you need to use parentheses. So you need to use parentheses if you're going to multiply. You need to put the whole denominator inside of parentheses. Otherwise, you're going to end up with the wrong number. It's not super visible, is it? It's a shame to go through all this work, get it all set up correctly, and then make a dumb mistake on your calculator and get the problem wrong. And, sometimes students, yeah, but I was so close, I just did this one little thing wrong. Yeah, well, if you're a nurse and the doctor tells you to give 10 cc's of this medication and you give 100, you just have the decimal point in the wrong place. And the patient dies, and they sue you, and here you are in court, and you're like, yeah, but I just had the decimal point one place over. It's not a big deal. It's a big deal. So details matter. Details matter in real life. So I'll see you guys on Friday. No, today's Friday. Have a good weekend. I'll see you on Monday. Oh, my goodness.